Hello friends, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with spectroscopy for chemistry. This is the lecture of IR spectra and lecture number 27, in which I will explain you application of IR spectra and particularly CH stretching and bending in alkyne. Alkyne is unsaturated hydrocarbon which contain C triple bond C and both carbons are sp hybridized. There are two types of alkyne. The first one is known as terminal alkyne. Terminal alkyne means there may be long chain of carbon with one end like R, but at another end you will find hydrogen. That means this C triple bond C will be either on the first carbon or at the end. Okay, so this terminal alkyne is one which has C triple bond C at the end of a chain. It has one CH bond at the end where carbon is sp hybridized. In alkynes, a strong band for CH stretching appear near 3300 centimeter inverse frequency, and this band will be normally on the left hand side of alkene CH as well as alkane CH. The band, due to CH bond occurs in the range of 700 to 610 centimeter inverse, which will be due to CH bending or deformation, and this band will be very strong. In some cases, the first Overtone, you know what is Overtone now, which I have already explained you in previous lectures. So first overtone of CH bending appears as a weak broad band in the regions of 1370 to 1200 centimeter inverse. Okay. Alkyne has C triple bond C group, a weak C triple bond C stretching occurs at about 2260 to 2100 centimeter inverse. Second is internal alkyne, in which C triple bond C will be between chain, and there are two types of internal alkynes. This here you can see on the left hand side as well as right hand side of C triple bond C, there are only R groups, same groups. So this is called symmetrical alkyne. And here you will see that one side is R, another side is R dash, that means another alkyl chain. So it is called asymmetrical alkyne. In case of symmetrical alkyne, here you will find same groups on both the sides. Therefore, net dipole moment of the molecule will be 0, and therefore this will be IR inactive. That means you will not get any signal due to stretching or bending of symmetrical alkyne. But if it is asymmetrical alkyne, because both the sides are different groups like CH3, C triple bond C, then CH2, CH3. So here alkyl chains are different. Therefore dipole moment will not be 0, and therefore this molecule is IR active, and you will find C triple bond C stretching. Okay. So here you will see that C triple bond C stretching nearly at 2200 centimeter inverse as a weak and sharp bands. So let us take one example so we understand how we will get IR spectra. The best example is this one. This is known as 1-hexyne or hex-1-ine, okay, in which you will find CH stretching. So triple bond CH stretching appear for this hydrogen, okay, which will be at 3324 centimeter inverse. This band appear because of this one. Okay, let us make change of this. This hydrogen and these hydrogens are same. So we have the bond due to CS stretching will be at 3324. Then there will be CS stretching once again for sp3 hybridized carbon, and it is due to methyl group, terminal group, which will be at 2971 centimeter inverse. Okay, this one. And you know that there is one methyl group over here. Okay, so you will get CH stretching because of this CH3 group. Then there will be CH stretching for CH2 sp3 hybridized, of course, but methylene groups, and you know that there are many methylene groups in this, and we will observe at 2879 centimeter inverse, and this is due to presence of these groups. Okay, CH stretching is because of methylene groups. Then we have CH bending, which is scissoring in fact, at 1470 centimeter inverse. Then CH bending, which is rocking due to rocking deformation, 1380 centimeter inverse. And C triple bond CH bending at 636 centimeter inverse. Okay, so this way we will get certain bands of one hexyne. When we observe the spectra of one hexyne, we will find this type of bands. Okay, so we come to know that this compound must be having one CH C triple bond C, and this must be at the end because we are getting CH stretching nearly 300. Okay, so that's it in this lecture. Thank you so much.